Hi everyone. In this video, we are going to solve equations involving fractions, including some application problems. So we have 4 learning objectives. Let's go through this learning objectives one by one. So first, we are going to solve equations with fractions in it. So whenever you have a fraction equation, you want to get rid of those denominators as early as you can, so that you can just solve, say, another whole number equations, right? So the way to do that is that we multiply each term on both sides of the equation by the LCD, least common denominator. So what is the least common denominator among the 3 numbers? 4, 3, and 6. And there are different ways to find the LCD. But for smaller numbers, such as these ones, and an easy way to do that is just by looking at the largest denominator. So we look at the multiples of the largest denominator one by one, until you find a number that is a multiple of both other numbers, the other 2 numbers. If you have more, have to be multiple of all of them. Currently 6 is a multiple of 3, but it's not multiple of 4, right? So that in that case, we just look at the next multiple of 6, which is 12. Next one is 18, next one is 24, and so on, right? So 12 is a multiple of 3. 12 is also multiple of 4. So this is our number. This is the smallest common multiple. So that's our LCD. So after we identify LCD, we just multiply each term on both sides of the equation. So let's do that. So 6 times 3/4 of x minus 6 times 2/3 equals 6 times 1/6. Now, as soon as you have this LCD multiplied by each term, you try to cancel this denominator, because that's the very reason we do this. And I said 12, right? I wrote 6. I don't know what happened. So let's replace 6 with 12. So 12 divided by 4, you have 3 left. Basically, we cancel this denominator. 12 divided by 3, you get 4 left. 12 divided by 6, we get 2 left. That's why we need a common denominator, which is common multiple of all of the denominators, so that when we divide by each of the denominators, they all cancel out. So now let's simplify it a little bit further. 3 times 3 is 9, 9x, minus 4 times 2, that's 8. The other side, 2 times 1, that is 2. Now we get a whole number equation. To solve x, we need x to be on one side by itself, and that is the reason we want to move this minus 8 to the other side of the equation. Whenever you move a term to the other side of the equation, you change the sign in front of it to the opposite. Since you move the term to the opposite side of the equation, you want to change the sign to the opposite too. So 9x equals 2 plus 8. Now that is 10. So 9x equals 10. Now we just have one more step to get x. We divide by 9 on both sides. So x equals 10 over 9. And if you want to write this into mixed numbers, that's going to 10 over 9. Because I teach too many algebra classes. 10 over 9. That is our answer. And if you want to convert this improper fraction, improper fraction to mixed number is going to be 1 and 1/9. So that's our answer. Now to check the answer, all you need is replace the variable with the answer, the value, and then to see if both sides are equal or not. So let's check this one. On the left-hand side, we have the check. On the left-hand side, we have 3/4 of x, 3/4 times x. X is 9/10. So 10 over 9. That minus 2/3. And if our answer is correct, we should get 1/6. So let's do this calculation. And always try to simplify fractions when you multiply them together. So 3 and 9, 3 canceled. You get 3 on the bottom. And between 10 and 4, both can be divided by 2. Now let's say what we get. 1 times 5 is 5. 2 times 3, that is 6. So 5, 6 minus 2/3. Now to do the subtraction, we need a common denominator. Apparently the common denominator is just 6 because 6 is also a multiple of 3. So this one can be written as 5, 6 minus 4, 6. If we multiply both sides by 2, we can make the denominator become 6, right? Now 5, 6 minus 4, 6, that's 1/6. So we get a correct answer. So 1 and 1/9 is our solution. Say the key logic behind this whole process is to get rid of the denominators by multiplying the whole equation, every term, by the LCD, least common denominator. And here is your first exercise set. All of the answers to the exercise questions are below the video in the comment area. Now let's look at our example 2. So we just have another equation. The only difference is that we have this parenthesis, and I'm only going to solve it without checking the answer. The point is that if your calculation is correct, the answer will be correct. Instead of doing the checking part, I'm going to do this problem twice, just to show you we have different ways to solve the same problem. So when you solve your own mathematics problems, when you take a mathematics course, you don't have to follow steps given by example. You just try to solve it, try to approach it in a logical, common sense way. And most time, it's going to be good. So understanding the concepts and the logic behind those steps is more important than following those steps. So first, I want to get rid of these denominators by looking at the LCD, right? Now, the largest number among these 3 is 5. Apparently, 5 is not a multiple of either of these two numbers. So next multiple of 5 is 10. 10 is a multiple of 2, but it's not a multiple of 3. So we look at the next multiple of 5, which is 15. Now 15 is not a multiple of 2, so we don't need to check the other one. Now next multiple of 5 is 20. Now 20 is a multiple of 2, but it's not a multiple of 3. So next one is 25. So 25 doesn't work for 2. So next one is 30. Guess what? 30 is a multiple of 2, and 30 is a multiple of 3. So 30 is our LCD. Now I'm going to multiply both sides by 30. So this is the method 1. We can just call it approach number 1 instead of method number 1. So 30 multiplied by 2/3, and this parenthesis. The other side, 30 times 1/2 x minus 30 times 2/5. Now make sure you don't multiply 30 by anything inside the parentheses. The reason is that we multiply each term in the equation by the LCD, each term. What is a term in the equation? A term is a single unit separated by either plus or minus. And this one doesn't have plus or minus. This is the parenthesis, its whole thing is multiplied by 2/3. So these two are connected by multiplication, not addition or subtraction. This one considered to be like one unit. They're connected by multiplication, not by addition or subtraction. That's why we don't multiply anything inside the parentheses by 30. So now cancel this denominators. 30 divided by 3, that's 10. 30 divided by 2, that's 15. 30 divided by 5, that's 6. If you cannot divide by any of these denominators evenly, that only means your LCD is not a true LCD. So now let's simplify it further. 10 times 2, 20. 20 times x minus 3. 15 times 1, still 15. That's x. And 6 times 2, that's 12. Right? Okay. Now we can expand this parentheses by multiplying each term inside by 20. So we get 20x minus 60 equals 15x minus 12. So now we need to move this x term together so that we only have one x term on one side and the other side is a number so that we can solve that x. So I'm going to bring this 15x to the left-hand side. At the same time, move this negative 60 to the other side. Now I get 20x minus 15x. Remember, whenever we move a term to the other side of the equation, we change the sign to the opposite. Now, this is a negative 12. Don't forget negative sign, plus 60. So apparently this is a 5x equals 60 minus 12, that's 48. So answer is x equals 48. We divide by 5 on both sides, 48 over 5. And if you want to convert it to a mixed number, 5 times 9 is 45. So that's 9. 48 minus 45, that's 3. So 3/5. And you can double check by multiplying this together. 5 times 9, 45, 45 plus 3, 48. So that's our answer. Now let's look at our approach number 2. And no matter which approach we take, our answer should be the same. So in the second approach, I just expand this parentheses first before we multiply LCD to see what happens. So 2/3 times x is 2/3 of x. Then 2/3 minus 2/3 times 3. The other side is half x minus 2/5. Now, apparently these two canceled. We just got 2. So rewrite it just one more step, step by step, right? Minus 2 equals half x minus 2/5. Now we can multiply LCD by each term to cancel denominators, or LCD remains 30 for sure because we have the exact same 3 numbers here. So 30 times 2/3 of x. Don't forget, every term should be multiplied by the LCD, even if it is not a fraction. 30 times 2 equals 30 times half x minus 30 times 2/5. Now 30 divided by 3, that's 10. And now 30 divided by 2, that's 15. 30 divided by 5, that's 6. 10 times 2, 20x minus 60 equals 15x minus 12. Are they the same? Are they the same? Yeah, they're supposed to be the same. So you know the rest will be the same too, right? 20x minus 15x equals negative 12 plus 60, and 5x equals 48, x equals 48 over 5, which is 9 and 3/5. Either way is okay, it's totally up to you. Okay. Now let's look at next page. I guess you have a exercise side first. Yep, that's a second exercise set. Okay, now let's look at our next topic. We're going to translate the sentence to equation, then solve. In other words, this sort of application problem. Example 3, the sum of 2 and 2/3 and 3/5 of n is the same as 2 less than 1/3 of n. Translate it to an equation, then solve it for n. So they ask us for n. So basically, whenever we set up equation, we just represent the information in the equation. So where does the equal sum come from? Whatever this sum is the same as this. The sum is the same as this. So we need to do the sum first. Apparently, we need to add 2 and 2/3 and 5/6 of n. Whenever you have a fraction of something, you multiply them together. So 3/5 of n. For example, half of $100. You know that's a common sense, right? That's 50. How do you get 50? Half times 100. That's 50. So whenever you have a fraction of something, you multiply them together. So the other side is they're the same. They're the same. 2 less than 1/3 of n. So you have to have 1/3 of n, then take 2 away from it to get 2 less than that. Right? For example, what is 2 less than 5? You say 3, right? How do you get 3? Say 2 less than 5. How do you get 3? You have this number first, then take 2 away from it. That's how you get the number. Same thing is here, right? Now, apparently, we have a fraction equation. Actually, we have mixed number. And before we multiply LCD, we have to convert the mixed number into the improper fraction first. And that is 8 over 3. So we copy the whole equation here. 1/3 of n minus 2. So between 5 and 3 is the smallest common multiple, which is LCD. Smallest common denominator is the smallest common multiple of these denominators. So it's 15. We're going to multiply 15 by each term. 15 times 8 over 3 plus 15 times 3 over 5n equals 15 times 1/3 of n minus 15 times 2. So cancel, we get 5. Cancelled, we get 3. Cancelled, 5 again. So 5 times 8, 40. 3 times 3, that is 9 times n. 5 times 1, still 5. And minus 30. Now, just like in the last example, I'm going to move variable terms together on one side, and number is on the other side. So again, 9n minus 5n equals negative 30 minus 40. So this is the 4n equals negative 70. Negative 70, we divide by 4 on both sides. So n equals negative 70 over 4. Both sides can be divided by 2, so negative 35 over 2. if we want to convert it to the mixed number. And 34 divided by 2 is 17, so negative 17 and a half. So that's our answer. Negative 17 and a half. Now, next one. Exercise again. Another application problem involving fractions. So basically this whole section is about working with fractions. Find the length A in a trapezoid shown in this figure if the area is 9 square feet. So we are given the area of this figure, we want to find the length of this side. So basically we need to know the formula for the area of a trapezoid, which equals half of A plus B times H. A and B are the length of the two parallel sides. No matter what letters they use to label them, there's no difference. Okay, just two parallel lines. And the height is distance between these two parallel lines. So we are given 2 out of 3 numbers and to solve for the third one. So we get our equation because we are given the area. So we just plug in this formula, area formula. Half of A, this is our A, plus B. Just 2 numbers add together, doesn't matter what you call them. Times height, which is 1 and 1/2. This should be equal to 9 because we're given that information. Now let's solve it. Convert this one to improper fraction first. Half of A plus 5 times 3/2 equals 9. Now this 2 can be multiplied together, this 2, to further simplify it. Remember in multiplication, there's no difference in terms of order. Okay, you can multiply any 2 numbers together in the multiplication. Let me give you an example. 2 times 3 times 5. If you multiply these 2 together, you get 6, then multiply by 5, then you get 30, right? How about I multiply these 2 together? Then I will get 2 times 15. I still get 30. How about let's rewrite that. How about I multiply the first and the third together? I get 10 times 3, it's still 30. So order doesn't matter. That's why I can multiply these 2 together first. So 1 times 3 is 3, 2 times 2 is 4. Now all we need is multiply by 4 on both sides. Since we only have 1 denominator, just multiply this denominator itself to cancel it. So I'm going to multiply this 4 on both sides. And say multiply by 4, canceled. So you get 3 times A plus 5 equals 36. At this point, you can multiply them out, or you can divide by 3 on both sides. Either way is okay. So I'm going to branch out to do it in 2 different ways, just to show you there's no difference. So first, I divide by 3 on both sides. So this is canceled. I get A plus 5 left. The other side is 36 divided by 3, that's 12. So move 5 to the other side, I get A equals 7. Because when I move 5 to the other side, it becomes 12 minus 5. Now, what if I multiply them together, expanded first? I get 3A plus 15, make sure you multiply each term inside, equals 36. Right? I move 15 to the other side. So 3A equals 36 minus 15. So we get 3A equals 21 divided by 3, A is 7. So you can see there's no difference. It's totally up to you. So we solve this application problem, geometry problem. Let's look at our next page. So we get another example application problem here. One is taking a course in which his grade is determined by the average, which is also called the mean of 4 tests. He has the following test scores in the course: 68, 85, and 90. In other words, he already got 3 scores, just one more to go. To get a B, he must have a test average of 80 on the 4 tests. What is the minimum score he needs on the last test to get a B? So everybody got this similar question when you want to have a B or A, whatever that grade you want to have, right? So basically, everybody understand how we calculate the average, right? We just add numbers together and divide by how many numbers we got. So in this case, we got 4 numbers, but with 1 score unknown. We only have 3, but nonetheless, we need to add all of the 4 numbers together. So we let the last test score to be X. So the total sum of 4 scores will be 68 plus 85 plus 90 plus X. That's a test number 4 score. We don't know it yet. So divide by 4, right? That's called the average of the 4 tests. Now this has to be as a minimum has to be 80 to get a B. That's why we like the average equals 80. So when we solve it, whatever this X value is a minimum number, because this is barely just exactly make it 80. If this is higher than a little bit higher, the average will be a little bit higher than 80. But this is the minimum requirement. So you can see we can add the 3 numbers together first. Let's do that using calculator. So we get 68 plus 85 plus 90, right? 3 numbers. So 243. So basically we have 243 plus X over 4 equals 80. Now we multiply by 4 on both sides to cancel this denominator. Cancelled. So we get 243 plus X equals 320. 4 times 8 is 32, right? Apparently, we just need to move this 243 to the other side. So 320 minus 243. Okay, let's see what we got. 320 minus 243. 77. So he has to get at least 77 in order to get a B. And this is your next exercise set. I have 2 questions, one is geometry, one is the average score, just like in those 2 examples. Okay, let's move on to our next page. We have another application problems. This time we have 2 unknowns. A small company has 2 salespeople. In one particular week, Benjamin's total sales are half the amount sold by Florence. If the total amount of sales for the week, both people's sales together, is 12,000, how much did each person sell? So whenever you solve a application problem, especially a complex one, and you want to focus on representing the information in the description, okay? Try not to focus on the answer. The reason is there's no way to get an answer when the question becomes more complex at a higher level. So we need a correct approach. And the correct approach is to representing the information correctly using an equation. Imagine if your representation is wrong, if your equation is wrong, no matter how you solve it, you can guarantee it, your answer is going to be wrong. So it's about the representation. Now, first of all, we need to have a variable to represent the unknown. So again, we want to set up equation and solve it. That's the general approach in real life tool, because there's no way just to do the calculation using arithmetics and to solve problem when you get a little bit more complex problem. Okay. So we have two unknowns. We don't know the sales for each person, but these two unknowns are related because the Ben's sales is just half of Florence sales. Whenever there's a relation between unknowns, you can represent all of the unknowns by the same variable. So in this case, basically, the reference is Florence sales. Whatever the number is, Ben's sales will be half of that. That's why we call Florence sales the reference number. So usually, it's more efficient in algebra to represent the reference by that variable, say x. So here x is Florence sales. Then as soon as we get we represent the Florence sales, we get Ben's sales naturally. So Ben's just half of it. So this is the Ben's. After we represent the unknowns, we can set up the equation. Equation is nothing more than both sides equal. So we're looking for information to have two parts that are equal. So basically, the total amount of sales of these two salespeople is 12,000. That means if we add these two sales amounts together, it's 12,000. That is why x plus half of x is 12,000, because these two represent their sales. Now, all we need is multiply by 2 on both sides. You can combine them together first, or you can just multiply by 2 either way. So I multiply by 2. Don't forget each term, okay? So this is 2x canceled plus x equals 24,000. That is 3x equals 24,000. Divided by 3 on both sides, x is 8,000. Don't forget x is Florence sales, because that's how we set it up in the beginning. Then this is the Florence. And the Ben's sales is half of that. Half x equals 4,000. How do we know if our answer is correct? If our answer is correct, they have to fit into the description. First of all, Ben's sales is half of Florence, and that is correct. Secondly, only other requirement is that the total sales is 12,000. Add them together, 12,000. So we get a correct answer. We just have one more example to go for this video. Example 6, figure ABCD is a rectangle. That means this is 90 degrees, 90 degrees, 90 degrees, and 90 degrees. Angle DBC, follow this the sequence. DBD is referred to this angle, is 14 1/3 degrees. So that's the measure of this angle. Oh, sorry about that. I have not finished reading it. I was too quick. So this angle DBC is 14 1/3 degrees less than angle ABD. So this one is smaller, this one's bigger. The difference 14 1/3 degrees. What are the angle measurements? So they ask us to find out the measurement of each of these two angles. So we don't know any of this for now, but they do have a relation. One angle is 14 1/3 degrees less than the other. Whenever, again, just like in the previous example, whenever there's a relation, you can use the same variable to represent both angles. And again, usually we use x to represent the reference one. So this angle is this much less than this. So this is our reference. Whatever this is, this angle will be 14 1/3 less than that. So this is a reference value. So we write X to be the measure of angle ABD. Then what is angle DBC? DBC is less. Less is 14 1/3 degree less than this, whatever this is. So this is X minus 14 1/3. So this way we represent both angles. You see general approach. After reading, after we understand the information, we want to represent the unknowns. And after that, we can set an equation according to the information given. So these two angles are here. Apparently, these two angles add together must be 90 degrees. This is just naturally true. So we just add them together, that is equal to 90 degrees. So one is X, the other one is X minus 14 1/3. These two angles add together is 90. And in here, this pair of parentheses is not necessary. I put them in there just to show you that this is one angle measurement, this is another angle measurement. Otherwise, in terms of calculation, it makes no difference. So combine them together, I get 2x minus 14 1/3 equals 90 degrees. They're all in degrees. Okay. Now all I need is move this number to the other side. And then we got 2x on one side. So 90 plus 14 1/3. Now we need to divide by 2 on both sides, but we need to combine them together first. So this apparently is 104 1/3. Now we need to convert this one to mixed number. So 3 times 104 plus 1. 3 times 104 plus 1. 313. So 2x equals 313 over 3. Now we need to divide by 2 on both sides. So x equals 313 over 3 divided by 2. Whenever we use a fraction to division, we change the division to multiplication. We change the second number to its reciprocal. So x equals 313 over 3 times 1/3. So that is 313 over 6. Now let's rewrite it into mixed number. Let's see how I do that. First, we do division to get a whole number part. 313 divided by 6. So whole number part is 52. Now fractional part. Fractional part actually is very easy to do. First, you subtract this result. Usually I don't write it down because it could be more digits not on display. Okay. And minus this 52. This minus 52. That's a fractional part. Then fractional part multiply the divisor. Whatever divisor you use to convert improper fraction to mixed number, which is 6, multiply by that. That's going to be the numerator in your fractional part. So that's 1 over 6. So 52 and 1/6 degrees. That is our x, which we designate as x. ABD, ABD. That's our x. So this one is 52 and 1/6 degrees. And the other one is 14 and 1/3 less. So the other one, this one is angle ABD. The other one is angle DBC, right? DBC. It's just 14 degrees, 14 and 1/3. So 52, 1/6 minus 14 and 1/3. So let's do it on the side and see what we get. This one is interesting subtraction. 52 and 1/6 minus 14 and 1/3. And let's convert it to, actually this is a better way to do that. But let's just do it in the traditional way. I don't want to give you actual information at this point to distract you from our focus, which is solving this application problem. So let's convert this to improper fraction first. And we already have that first number, which is 313 over 6. Second one, 3 times 14 is 42 plus 1, 43 over 3. And we need a common denominator, which is 6. So we'll multiply second one by 2 on both sides. So we get 313 over 6 minus 86 over 6. So 313 minus 86, we get 227. So 227 over 6. Now we convert this back into mixed number. 227 divided by 6, we get 37, and so we're going to convert this decimal part 0.83333 to the numerator in the fractional part in this mixed number. So subtract 37 to get decimal part, then multiply by the divisor, which is 6. That's 5.56 degrees. So put this back at here. That's our answer. 37 and 5.6 degrees. 37 and 5.6 degrees. Now, do we have correct answer then? First, apparently this one is 14 and 1/3 less than that because we just did that. Now, do they add to 90 degrees? Because this will have to add to 90 degrees to be correct. Look at that, 52 plus 37, that is 89. 89. 16 plus 56, that's one more. That's 66. 66 is 1. 89 plus 1, 90. So we get a correct answer. So you see, solving application problems are not, it's not that hard. You just need to represent the information correctly. And then solve the equation, make sure you don't make calculation mistakes, then you're good. And that is all for this video. Any comments are welcome. And see you guys in the next one.